demoscene 64K softsynths with a question mark. So I'm Red, this is BeRo. BeRo asked me to talk for the seminar because he can't. So, and to be honest, until last week I did not really know what the seminar was going to be about exactly, but then we started working. And so we're going to talk about synthesizers. So what do we need for a 64K synth? What does a 64K synth have? What are the features that a 64K synth needs? And it's basically quite simple. It needs to be small, flexible, and somehow usable. So small is not the hard part, because most DSP code is not so huge. If you're not using big lookup tables, you can fit your synthesizer code into a little space with no problems. Flexible, that's a bit more complex. The better, the more variety you can do with your synthesizer, the better. It must be versatile enough to make a complete track with it. You must also do post-production. Mastering, it's a plus. It's not necessary, but it's definitely a plus. And it should be usable. It doesn't have to be user-friendly, but it should be usable. So, yeah. So, the idea, runtime code generation. The idea is that you write your synths and effects in your patch editor, press the compile, and instantly hear your changes. This has a lot of benefits, like really short turnaround times if you want to play around with your synth code. So yeah, we have a JIT compiler in the editor and store just the compiled object file in your intro. Yeah, and the biggest benefit, your synth is no longer limited to your own DSP routines. So even if you're new to synthesizer programming, if you do the actual DSP coding into the user land, you don't have to worry about that during the writing of your synthesizer. What do you actually mean by host language independently? It's the point you just added. Yeah, the host programming language doesn't matter, because you might know that BeRo writes in Object Pascal, and so do I. So all you're going to see is written in Delphi, actually. We're going to do a live demo of what we came up with in a week. So we're going to actually do live synthesizer coding. Let's see how that will work. So yeah. During the last week, we encountered quite some challenges, like how do I actually implement this? Last weekend, BeRo gave me his compiler code, and it was able to compile code during runtime, and gives me back entry pointers, and I just can call functions that I've written in this language, language that BeRo designed. And another plus is how to make this usable for non-coders. Even though I can write my own code in my synth, I maybe want to give non-coders a chance to also use the stuff I've written. And another very technical issue is instancing. So I've written an effect or an instrument, and I want to use multiple instances. I have to care about memory being allocated for all the instances, but without storing the effect code multiple times. So, and also important, when I'm writing code in my editor, I want to concentrate on the DSP coding. I don't want to care about counting MIDI active nodes and stuff. I don't want to care about this. I just want to write DSP code. So all the ugly logic, which does not have to do anything with DSP coding, is actually in the host program we've written. So talking about the implementation, so BeRo wrote a compiler. He designed a language called Aulan. I think. We've never spoken it out in English. So it's a very basic compiler. It just supports integer, boolean, float, arrays, structs, functions, pointers, inline assembler. And it translates to native assembler. It's native code. There's a special feature called instance variables. So it's like global variables, but they're not. You can have multiple instances, and when you choose a different instances, the instant variables will be allocated to a new memory block. So we can run multiple instances of the same code with no problems and without much code changes. We actually just have to set a register accordingly, and we have a different instance. Set, whatever. Language features, it's a mixture of basic Pascal and C, and new line means it's end of a block statement, always. As already said, compiles to native code and links during runtime in the editor. In your intro, you can either use the generated assembly files, which the compiler generates, or you can use BeRo's runtime linker code he written, which links the object files dynamically if you store them as byte arrays. Or you can use your normal linker if it supports COFF files. So, before we're going to take a look at what we've done, let's take a look at synth design in general. So there are different layers in a 64K synth. So there's the most basic layer is the voice layer. It's the code that gets executed per active node. In classic synths, we have a fixed pipeline. That means we have like an oscillator and another oscillator and a filter and whatever, and it's all fixed. A fixed pipeline has a benefit that doesn't need so much CPU power as it's the most time-critical code. We also have the channel layer, which processes the sum of all active nodes of a single instrument, and the global layer, which does the same but for multiple instruments. Maybe you could say that the channel layer and the global layer are the same. Like, we have you probably know bus, where the channel layer and the global layer are the same, basically, because you can have your generators and you can chain effects to that and build your build effects that are only for one instrument, or you can build a mastering chain. So these are the most important layers. So fixed pipeline versus dynamic pipeline. So what do I mean by what's a fixed pipeline? It's a set. All your code is static. All your oscillators, filters are static. They have a static path. A good fixed pipeline can be very versatile indeed. It's small, and the only drawback is you need a good fixed pipeline. So if you don't know anything about synthesizer design in general, you should ask your musician about this. And in a fixed pipeline, you might have global hard-coded effect chains or send-to effects like that. You can say, okay, I want this instrument to have a bit of delay, reverb, if they're all hard-coded. So that's a fixed pipeline. And dynamic pipeline is like, you might know this as modular synths. Not all modular synths provide modularity on each level, like bus again. We don't have modularity on the voice layer. But if it's done on the voice layer, it allows very complex synth patches. So you can say, okay, I have this oscillator and I want to connect it to anything, filter, distortion, whatever. Hast du das wieder editiert? Also, was habe ich denn da? It's more implementation work, I guess. That's what I wanted to say. Because the more granular you design your modular synth, the more work you have to provide all these features. Because to have a good modular synth, you have to put a lot of work into providing all the basic features you need to build a basic synthesizer. another good part is you get a mastering effect chain for free, basically, if you're using that approach. There's also a hybrid, synths which are kind of dynamic, but not really. There are really a lot of different implementations out there, so we can't really go there into detail. There's just too much different possibilities how that can be done. Yeah. Another very important aspect about synthesizer programming is parameter modulation and envelopes. It's very important to make dubstep. Also, it's important to make your sound sound alive, because having just a simple oscillator with no changes sounds very, very clean, very lifeless. I will show you later. So there's different approaches to fix those. You might know modulation matrices, where you have input oscillators, and you can map them to other parameters of your synth, like filter, filter, volume, pitch. And then again, there's a modular node-based modular approach, where you can basically, if you have a node system, and you might be able to plug certain LFOs to parameters depending on your implementation. And of course, in classic fixed pipeline synths, we have LFOs, where you can choose different targets like volume, filter, pitch. If you implement this wrong, you might get bad performance, because this is really time critical. You might not want to calculate a LFO parameter automation every sample, but you can interpolate between values to not call the whole calculation process each sample, because this really gets CPU intensive soon. So we wrote a synth, basically, and we didn't have much time, so it's kind of unfinished. The concept is stolen from Buzz, but instead of plugins, effect plugins and generator plugins, you write code. The idea is pretty simple, actually. At the moment, all machines can be assigned to a MIDI channel, and variables, global variables you write in code, can be exported as parameters, and these parameters can be bound to MIDI controllers, so you have good live usability, hopefully. So maybe we just take a look at this. This will crash so hard. Haha, ist kaputt. Bitte warten. Boah, wie viele BeRo-Verzeichnisse hast du? Was habe ich kaputt gemacht? Ah. Yeah, if you have questions, you may ask them. BeRo can't answer them, but I might. 391. Habe ich da gerade ein Komma eingefügt? Ach, da ist Tab Build Down. Das macht doch keinen Sinn. Ach so, vielleicht sollte ich auch. Maybe I should use the right comment. It's all BeRo's fault, because in his language these are comments, and guess what I've been writing the last days. Oh. So, Medien 2. Ach so. Ah, okay. Okay, it's way too early. Usually I code at night, so. Yay! So, you might know this. There's just two buttons. Add Generator and Add Effect. So, kann ich das hier verstecken? So here we have code. So there's an initialization procedure where you can put in where you can initialize your variables, and here are the instance variables. So you can see it's a very simple and it's a very simple language, maybe a bit too over-designed. And here's a node on event which uses these instance variables to calculate the phase increment. You might know this. This formula. Node off just sets a flag that the node is off, and here we have the actual processing of the active node. So should we try? If I just connect this to the master output and set this to channel 10. Ach so. Ach ja, das ging ja nicht. Yay, it works. So, what should we do? What should we do? Well, so what we have here is the starter code that I've written, and maybe we just could add a parameter, and for this I just define a variable, and I call this global volume, and it's a float. And now comes the tricky part. I write here a description, and I set minimum and maximum values. And in the initialization code, I of course want to give this variable an initialization value. And in my synthesizer code, I just want to use this global volume, I think. So did this work? Yes. And now you can see I have here a parameter which I can set, and you can hear that it even works. And I also can assign a parameter to it, so I can just use the MIDI device to control this parameter. And we've also written a stupid preset manager where we can load different patches. So now I have a buggy gut. So, but it's buggy. Why is it buggy? Because in the processing function, the processing function actually has a return value where it says whether the node is still playing or not. So when you write like envelope and you want to stop the node when your envelope is finished, you just have to return true or false. So right now you can see here that I faked a release, envelope release. So maybe I just should tweak this parameter a little bit. And that works better. So we also have effects. Yeah, I can also learn CC map parameters to MIDI here, but why should I do this now? Ach so, ich soll ja mal, ach, dann mache ich das hier doch einfach mal. So. Welchen habe ich denn hier genommen? Bin ich jetzt doof? So this all works, actually. So I'm impressed myself. And we also have effects. Effects are a bit simpler. They just, here it is. Just a procedure where the buffer gets processed. And you might see that this function procedure just gets a pointer. And actually getting a whole buffer, it's not per sample base, because that might be too CPU intensive. So we can see we have here the while loop. And while while we have not finished processing the buffer, we just copy the output, the input to the output. And as everything is stereo, we have to do this 2 times. So also here we have maybe a little presets. So if I just connect this to this and disconnect that. Also here I can, I can map parameters to MIDI. So if I so that also works. So I don't know, what should we do? I'm out of ideas right now. Dubstep. So you want dubstep. Well, we need our LFO. So where do we implement the LFO? We could basically we need the filter in the generator code, because we want not or we just put an LFO onto the volume, because that would be cheating and it's really faster. So I make a new parameter here, like LFO speed. It's also a float, and let's do it like this. I don't know what will happen. Maybe the range is not good, but maybe it is. So, and in the instance, we also need an instance variable for the active node, which is, how do we call that? Like, just call it LFO. That's okay. So we also have to initialize this. So this is actually a pet synth, whatever. I forgot what BeRo implemented here. So here. And I'm just gonna add the code. Now, if I only knew, how did I call my last global variable parameter? Does anyone remember? LFO speed. Thank you. So it's the whole editor is very buggy actually, but why did I have to write it all myself? I don't know. No. So we also have a commented out volume parameter, which we are using as well. And now let's just do this. Maybe at a plus, because addition is good. And it compiled. And you can actually see here the size of the synth. So let's map this. Yep. That doesn't work. That's great. Maybe I should, I don't know. Let's try this. I have no idea what I'm doing. I'm a dog. See, das ist obwohl. Okay, who sees the bug? Yeah, it's the frequency. Should I go lower or higher?
Lower.
Even lower. Yeah, I probably should. It is there, but because of the effect, I think the effect is no. The effect is doing nothing, so it should no.
Increase amplitude. It's actually a modulating, but you can't hear the effect very well.
Habe ich doch. I even initialized the LFO variable. I did that. Guck mal hier. Was schreibst du so scheiß Code? So, okay, this is not the best way to do things, but let's just write the whole thing again, and maybe it works now. Press compile again. So let's so we have an LFO. Actually, it should be on the filter, but the filter is global. It processes all active nodes. I don't know if we want that. Could do the same in the filter. I could write distortion, because distortion is fun. So what do we do here? Let's just take this input and multiply it by 10. And if this is, and if this is greater than 1, then we just set it to 1. And I hope the compiler does the right thing and interprets this as float, but I guess it does. And if it's... da hast du das schon mal. Dann sollte ich das wohl nach da oben packen. Okay, I basically get distortion for free if I do this correct. And maybe I should just do it like this. And here again. Because we have clipping here, and we want to clip our sound after we amplified it. So, Bild hoch. Minimum value should be 1, of course, and let's say 20 is maximum. What could possibly go wrong? Oh. Why do we have a foo command in here? Thank you. Does this work? Yes, it does. So let's map this parameter to it. Actually, it just amplifies. It doesn't really distort the sound quite as I expected. So what can we do about this? We can change the parameter range again. And when I recompile and I have a parameter, actually remembers the old value, so I don't have the problem that each time I recompile my code, I have the original initialization values. So it doesn't work that way. Was? Ach so, soll ich ja mal auch richtig aufdrehen? But yeah, you can see I'm quite flexible with using this, even if the tools are so unusable as they are right now. I can't even load or save my work here. I just can save patches. So what could we do? Any interesting more effects? Yeah, have a simple delay. And oh, there's actually a bug. So you can see it says that the size of this delay is about 32 kilobytes, but that's with a delay buffer. And in your intro code, you probably don't put this in as well. So that's a bug. It's actually much smaller, this code. If I decrease the buffer, you see it's just 4 kilobytes. So let's maybe just connect this. And we have a delay, and it's a really simple delay because the whole thing didn't work before yesterday, so we didn't have the time to write good presets. Maybe next time. So yeah, the delay is again very simple. It's a mono delay actually. So the output of each channel gets added and is stored in a delay buffer. And also we add the delay buffer to the output of the left and right channel, and we have an instant delay. So any more suggestions, any questions? What do you want to know? Yeah.
When the tool will be available for normal users?
For normal users, you mean when it's finished?
Not nearly finished, but
usable.
maybe with a save and load option.
Yeah, well, as said, we put this together in a week. So
next week?
No, I think we are definitely going to release something based on this, as it was really much fun working on this, including a compiler. Yeah. As BeRo wrote the whole compiler, I'm not really the right guy to answer all the technical implementation details, but we definitely want to release something because it's really great for synthesizer learning and maybe even synthesizer design for 4K. If you just want to write a proof of concept code, you can do it in here as well. So yeah, any other questions?
If you don't do real stereo processing, so with different parameters on each part of the stereo spectrum, wouldn't it be more efficient to have the generation or alteration routines only written once with the parameters? So you call the alteration routine for the left channel, change the parameters to the right channel, and call it again, instead of writing and maintaining code for both channels?
Maybe, yes. We didn't put much effort in this designing. Maybe we're going to redo the whole bus rip-off and do a different thing, because a couple of things don't work in this design, such as sidechain input. There's no way I can do sidechain compressing with this, and that's really bad. We have to think about this. You're of course right. We have to maintain code, which is kind of ugly if you're not doing any, if you're not writing stereo effects, and maintaining the code is something you don't want to do in this code, but in your host code. So we'll see about that.
This wasn't meant as a criticism, but just as an idea.
Yeah, no, it's a good idea, of course. So just saying that we faked all this in no time. we will consider that, definitely.
How do you actually write music using this? I get how the synth work, but how do you get music MIDI data and the modulations? What's your plan there? The plan is that you could use a MIDI loopback device and use your standard sequencer to
We might also do a VSTI plugin if we want to. Probably makes sense. This implementation doesn't even have program changes, so you can't do program changes. You just can assign machines to one channel, and that's it. So it's not really complete yet. It's just a proof of concept that this might work. Anything else? Does anybody want to code? Nobody. What?
Can you make some wop effects?
I could. Nah, that's not really. The other LFO, which does process the volume, doesn't really match with. Was it good enough? Okay, so yeah, we're still working on this. I'm happy it even works at all. So yeah, any other questions? Nobody wants to try? Works. It's can play if you want to. Okay, nobody wants to, so. Thank you.